says y prime equals xy over 2 ln y. Okay. And so the first thing I would do probably is just take the y prime and write it as dy dx, just so that I can think about it as like, oh, I'm going to get the x's to one side, I'm going to get the y's to the other side. And then I probably want to take this and think about how I could separate the x's and the y's from each other, just to think in terms of like, how could I get the x's to one side, get the y's to the other side? Does that make sense? Okay. So, does it make more sense to keep the x with the 2 or to keep the y's with the 2 on the bottom? Do you guys want to take the 2 and put it with the y's? Take the 2 and put it with the x's. The y's, you want to move the 2 with the y's? It doesn't really matter. Think about our goal eventually, right? So whatever goes with the y's, eventually we're going to isolate y. Does that make sense? So if you have a number, it might be good just to leave it with the x, because eventually we're going to try to solve for y. Does that make sense? Okay. So are we okay with leaving the 2 with the x's for that reason? Okay, so I'm going to think of this as like x over 2 times y over ln y. Now, you're not going to get the problem wrong. If you did y over 2 ln y, you're not going to get it wrong. You can still do it right. You're just going to end up having the 2 on the left side and then moving it back over to the right side. Does that make sense? Okay. So all I did right now is I just thought about it in terms of like things that I could easily split up. Does that make sense? Okay. So what do I need to start doing so that I can separate these things? Think in terms of like I'm integrating. I've got something with the dy, I've got something with the dx, I can integrate both sides, all of that. What do I need to do? Okay. So when I take the y's and move them to the left side, what is the left side going to look like? Okay, so I'm going to have ln y over y dy. And then what am I going to have on the right side? X over 2 dx. And are we okay with me writing 1/2 x, writing it like that? 1/2 dx, okay. So I'm just doing that because most students are used to seeing it written as 1/2 as a coefficient as opposed to x divided by 2. Most of us are just more comfortable. Okay, so now what should I do? Integrate both sides. Okay. All right. So if I work with the left side, I have an ln y over y. What do we notice about that? It's a rational function. It's got an ln. It is a u substitution. Can you tell what the inside would be? Would it be the y? Think about what your function is versus what your derivative is. The ln y. And then what's the derivative of ln y? 1 over y. Does that make sense? So normally we would say the u is the bottom. So that was a good recognition, is that typically the u is the bottom, but this would be an exception to that because the derivative of ln is 1 over y. So this is like the one situation where it's not the bottom. Okay? So we're going to say u equals ln y, and then du is 1 over y dy. Right, so if I rewrite the left side, what do I have? Yeah, I've got u du. And when I integrate u du, what do I get? 1/2 u squared. Okay, so I've integrated the left side. When I integrate the right side, is that a u substitution problem? No. Okay, so how do I integrate the right side? Okay, so I'm gonna keep the 1/2 x. I have an exponent of 1 currently, so I'm gonna add 1 to the exponent, divide by 2. Okay? So what does that give me? I'm gonna drop my equal sign down. So what does this give me? 1/4 x squared. Now technically both of these have a plus c and a plus c, but they're different plus c's. This one would be like plus c sub 1, this one would be like plus c sub 2. They have a constant added on the end, but it's a different constant. I'm just going to write plus c on one side and pretend that we like moved all the constants over to the right side. Okay, we comfortable with that? Okay. All right, what should I do now? Switch the u with what I knew u was, right? Okay. So 1/2 lny squared. Okay, big picture perspective, let's remind ourselves what we've done. What has the process been so far? We started off with a differential equation. And then what was our goal? Okay, x is to one side, y is to the other, and then what was our next goal? Integrate. Okay, now what is our goal? Isolate y. Okay, so basically you're doing 3 steps. Get your x's and y's to one side, then integrate, solve for y. Make sense? Okay, so what should I do now that I'm trying to solve for y? Okay, so times 2 times 2. All right, so those cancel. So we have ln y squared equals, and then what happens when I take 1/4 and I multiply it by 2? 1/2 x squared. And if I take a constant and multiply it by 2, what happens? It's still a constant, so I'll still write it as plus c. You can make it a 2c if you want, but because we haven't tried to plug any numbers in, a c and a 2c, it just means that your c represents something slightly different. So people who left it as c, let's say that the plus number at the end ended up being plus 8. So people who ended up solving for the c and they left it as like just a plain old c, when they solved it at the end, they'd be like, oh, c equals 8. If you distributed the 2 and you had 2c, then when you solved for c, you'd get c equals 4. But you'd still get plus 8 at the very end of the problem. See the difference? So everybody would get plus 8 at the very end of the problem, but one person would just leave it as plus c throughout the problem. One person would leave it as plus 2c throughout the problem. But they'd still solve it and get the same thing. So it's just a matter of keeping things from becoming unnecessarily complicated, because since we are carrying the math through the problem and not plugging things in until the very end, it doesn't really matter how we carry that out because it's not a variable, it is a constant. Does that make sense? And so there doesn't need to be a coefficient there because the c is never going to have we never mess with anything in front of the c. It's always stuff is being plugged into the other terms, and then the c is just whatever is left over. Does that make sense? Okay. So that's why it doesn't really matter, and it's just a little bit easier to just say the C basically absorbs everything that's happening to it, and that's like the common practice, is just to say a constant multiplied by a number is still a constant. A constant that's been square rooted is still a constant. A constant that's been divided by something is still a constant. That's what people typically do. Yeah. Make sense? Okay. All right, so what should we do next? Square root both sides. Ellery, we're just doing number 8 right now to get our brains warmed up. All right, now with this root, we would say that we have 2 answers, the positive version and the negative version. If we look at the context of this problem, is that going to happen? So think about the left side, think about what you're square rooting. So think about like ln graphs. You can't plug in negatives. Yeah, so sometimes they have negative outputs, but typically positive outputs. If you picture an ln graph, it looks like this. Does that make sense? Okay. So since we were square rooting this, but it said ln y squared, this should have been a positive graph or a positive output. Does that make sense? It shouldn't have had a negative output. So that's why we're not really worried about saying, oh, we have 2 versions plus minus. Saying that this is a positive output is pretty safe to say. Does that make sense? So sometimes if you are looking at an answer key and it doesn't say plus minus and you're like, but we always have to say plus minus, just look back and say, is there something about what I'm square rooting that makes it so it would always be plus? And then that's probably why. Okay. So in this case, we're not too worried about there being a negative result because of the ln. Does that make sense? Okay. All right, so we've got that. We square rooted. Now we've got ln y equals square root 1/2 x squared plus c. And what should we do next? Say it again. Multiply by e, but it's not called multiplying, but you're fine. It's called exponentiating when you put an exponent base. Because you're not actually multiplying, you're putting a base in there. So if you put an e in there, you're adding a base of e to the problem. It's called exponentiating. Yeah. Because you're not actually multiplying by the e, you're making it the base of the problem. Yeah. It's a weird word, and I did not know that until I was a teacher. So you were already ahead of me because now you've heard that word in high school. Exponentiating. All right, so we've got y equals e to the square root of 1/2 x squared plus c. Wasn't that so fun? Aren't you glad this is the one we did together? You guys could have done it, but your brains would have been a little bit tired. All right, so big picture perspective, get the x's to one side, the y's to the other, integrate both sides, solve for y. So all things that we've done before, we're just tying it together in a different way than we've done before. All right, sound good? Okay, so you've got the Larson page, you've got the punchline sheet, and then when you guys are done with that, I have a quiz review for you because we do have a quiz tomorrow. So there's no video notes tonight. Tomorrow is quiz review and quiz in one day, so make sure you do start the quiz review tonight so that you are not rushing tomorrow. Okay? All right, go ahead and get started. Yep.